About 10 years ago, I don't know if anyone noticed, but oil companies were no longer oil companies, they were energy companies. Anyone kind of knows that little subtle shift, that's hard to say. What if mining companies, but mining companies still are mining companies, or they're gold companies, or copper companies, or phosphate companies. They don't consider themselves to be resource companies. They don't take value of all the resources that they potentially have. What I'd like to do today is present some R&D that's been happening in California for about the last 15 years, where we can start looking at some of this waste material in slightly different components. And in some regards, it is a reprocessing of waste material. Most of the conversations we have been happening is with active mines and actual miners, but there may be some applicability in the abandoned mine land space as well. Hey, there we go. When we think of waste, we tend to think on the left-hand side of this curve in terms of toxicity. We tend to think about those components and that. And certainly, I spend a large chunk of my waking hours thinking on that side of it as well. As a geochemist, I'm always looking at waste characterization, waste fate and transport. What impact does that have to human health and the environment? But my other interest is actually on the other side, the right-hand side, is the deficiency side of things. What impact does deficiency in our soils in terms of agriculture have in terms of human health? There are relationships between the quality of our food, not just the quantity of our food, and our agricultural practices take this out. Now again, this seems a little bit strange perspective here at a mining conference, but bear with me, I'll bring it back around. I became interested in this about 20 years ago. In fact, in the Uncompahgre Valley, I actually lived in the Uncompahgre Valley 20 years ago, and became very interested working with some veterinarians who were looking at this, how do we improve pasture health in terms of improving animal health to reduce the cost of healthcare. So with that, I fell down on this particular path. And again, bringing it back to the mining side of things, there is actually some interest in this area from some of the mining companies. Teck up in Canada, Canada's largest mining company, is showing some interest in how can they use some of their products to overcome some of these nutritional deficiencies in the area. So as I said, hang in with me, I'm going to bring it around. So about 20 years ago, as I said, 20 years ago, I went back, I had a year sabbatical here. In fact, June 29th, 1997, so 20 years ago, I got married in the Ouray County Courthouse. So I'm about to celebrate my 20th anniversary here, so it's nice to be back here to kind of round this back up. But I went back to Australia, and I did a PhD where I basically was looking, can we extract the mineral nutrients we need out of rock and get it into an agricultural setting? And basically I took as a geologist, I said, well, I looked at it from a very geological standpoint and tried to beat the crap out of it to see if we could get something to come out. 4 years later, the answer is not really. But what I came to understand, though, was the importance of the biological components in this system. And certainly over the last 20 years, certainly in the last 10 years, there's been a lot of real work in terms of this concept of biomining. Can we use biological components in order to release the commodity out of the ore body? And as you can see, there's a lot of interest in this just because in terms of costs and footprint and permitting and all of these components. And there are cases around the world where it has worked effectively. In Poland, the shales are subjected to this process and that there is commodities extracted out of this. But it's still kind of working through. But about 15 years ago, there was a group out of California that started looking at this process initially as a way of extracting gold and silver out of the waste rock. This was their thought: can they actually take it? But what they came to understand was that in addition to being able to pull out the commodity value out of waste material, they were able to also create another commodity, which was effectively a biomineral fertilizer that they were able to begin growing, plants, obviously, in this material. But as you know, just like any other mining application, no two ore bodies are the same. And saying that if we're looking from the fertiliser component, there's not one feedstock that can give us what we're looking from a nutritional standpoint. So we tend to be looking at a different range of commodities. And here's some work that we're doing. We blended 3 different rock types to create a blend that gave us a good range of nutrients from a plant growth standpoint. A couple of things to notice though, still not complete. We know that selenium is very important in animal health, and yet in this blend we were unable to get selenium. However, we have a little bit of arsenic, but we have no mercury in this system. But I'm going to come back to mercury in a minute. And the process that they began working on was a 2-stage process. And the first was basically a slurry leaching step. The solution they use is non-toxic, but it's also proprietary, so I can't actually share that with you. But through that step, they were able to create basically the kind of material that I was working on in my postgraduate work, which has value as an amendment, but not necessarily as a fertilizer. But what they were also able to do in this particular step, so that it was a leaching process. They extracted out the solid into this fertilizer component, but then there was also a liquid extraction. What do they do with that? They then run that through a resin column effectively, and are able to extract out, in this case, gold, but they've also been able to extract silver out of this. And these are some old tailings. You see the tailings and waste rock out here in the west, and they're able to get reasonable recovery out that. They're also looking at a tailings material in Nevada that was an old amalgam silver mine. So there's obviously a lot of mercury in that particular system. And using a similar process, they were able to also extract out the mercury out of that system as well. So we're still doing more work on that side of things to see, can we take some of the more toxic mine waste and extract mercury, arsenic, these materials out of it as well. So it kind of has a dual purpose in the actual process itself. So this is the solid piece. So if you remember, we had this is the liquid piece. If you remember, we had a solid piece in there as well. So if we take that piece and then basically put that through a biodigestion process in there as well, and extract out a fertilizer component within it. So basically what we're calling a biomineral fertilizer, as well as a liquid fertilizer component in there as well. So at the moment, we're currently running some large plot trials in California. In this case, this is some almond growers in the Central Valley, but we've also got some other work going on as well. And the early results out of that, the almond on the right has been treated with the fertilizer. The almond on the left has just been a normal fertilizing practice within there. We're getting these results over and over again, and we're getting a lot of interest, certainly out of growers in the Central Valley, which, as you can imagine, is a fairly large supply. So obviously, where we're at the moment is that, I mean, the R&D is all well and good, and it all sounds really good, but if you've got no market, then there's no point in actually doing it. But it looks as if we've got a market that we're working on right now. We're in the early stages of processing of a project in Nevada to see if we can actually take it to the next scale and get it to a pilot scale process within there as well. Now, because I actually currently live in Colorado, I'm allowed to have grow operations. In this case, we're also trying to work out, can we also take that material and use that as a way of reclaiming mine sites as well. You know, with any of these issues, any of the abandoned mine sites, for example, access is always an issue. Trucking material in and out is an issue. One of the other advantages of this particular process is it's fairly self-contained. You can basically fit one of these units in a shipping container. So you can put it onto a remote site and it's effectively self-contained. It can have effectively all its self-contained power. It's also scalable. So you can just keep on adding on different, more and more of these containers as you want. So another option in terms of some of the problems that we're dealing at here in the San Juan may not necessarily be pulling material out, but can we use this as a way of getting material to grow on site as well. So that's one of the other components that we're starting to look at as well. The engineers among us will always ask me the question, well, how much does it cost? It's always kind of the first question, so hopefully the engineers and the thing in the audience, I'll quote that. Current economic models say we're looking, in terms of extracting an ounce of gold, is about $400 an ounce, which is actually quite reasonable. And that's just on the metal recovery side of things. The real value that we see to it is not necessarily the metal recovery as much as the fertilizer. And if the markets develop the way we think we're going to, there is huge potential. I put the intangibles there. As I said, most of our conversations I'm having is not necessarily on the abandoned mine side of things, but more on the with active miners and some of the social license associated with this. I was in Arizona yesterday looking at some of the larger operations down there, and I just look at the sheer scale of the waste material that they're handling down there. I was in Montana a couple of weeks ago, same thing, just the scale of some of this material. Are there opportunities to really remove some of these liabilities for the miners, as well as some of the social license associated with that? Known unknowns. So obviously there needs to be, what is the revenue model associated with that? That still needs to be worked out. Regulatory compliance. I would assume that this is, if we went this, it would be a remining operation. We would permit it as such. But of course, there's still some legalities around that. Who actually, if we're on an abandoned mine land, who owns the liability? How does that all work in? And then obviously tying in with Lauren's talk as well. How does this play in with the Good Samaritan piece? All of these things still need to be worked out through this process. As I said, we're looking at a facility in Nevada. We hope to have that up and running, in the foreseeable future, and take it to that next level. I'm looking for any material that you think may have a high arsenic value, because I think there's a lot of opportunities in treating arsenic waste in there as well. So if anyone has some material they're interested in, please come and see me. If there are any other opportunities, please come and see me as well. I think in the next 12 months, we're really going to know if this is truly an economically viable process as well. However, all indications are that it is. Thank you for your time. I'll take any questions.
Did you say that the gold was recovered in the resin?
In a resin, that's right.
And so what did you use to leach the gold?
It's a proprietary blend. I can't share that with you. I'm sorry. If we want, we can have further conversations, but I can't in a public forum tell you.
Well, there's only a couple of ways to get gold.
Right.
It's either cyanide or aquaregia. And so does that $400 an ounce cost take into account environmental?
In what way? So I don't understand what environmental.
In other words, it's, if you're using cyanide or aquaregia or some other method to leach gold into solution.
Sure.
There are, for mining companies, there are significant environmental implications of the process. And those all go into the cost. The cost per dollars is lower than most mining companies producing gold. So
Right.
It's quite interesting.
Yeah, and I'm happy to have a conversation offline with you. I just can't do it in a public forum.
Do you have in this process, you're pulling out certain metals.
Mm-hmm.
Do you have a waste product then? There are metals that you're not pulling out and using, or any water or anything?
Yeah, so obviously, and that's what I was making on the fatal metals, such as the mercury and the arsenic. At the moment we need to work out where that goes and what that particular pathway is. But at the moment we're still just trying to play around. Can we actually work through those particular wars as well? So yes, yes, there is a waste product if we're looking at mercury or the arsenic side of things. But what we're dealing with at the moment, we're dealing with a fairly benign waste material, so that all of that then goes into the fertilizer stream. Yes. No, not yet. Are you interested? Yeah, there's certainly potential for marijuana, for the marijuana industry, as there is for any plant growth industry.
I just
Oh,
I
okay.
make a point that the old timers tell me that back in the 20s and 30s, some of the farmers in the flatlands of Colorado would go up to the mining districts and basically arrange to have waste rock loaded and shipped from mine sites down to their farms so that they could plow it in to rejuvenate the mineralization of their
Right.
soil. So it's not like it's never happened.
No, it's not like it never happened. There's good data around that. I mean, certainly,
Yeah.
the veterinarians are, love that whole concept of remineralization. So yeah, there's plenty of good, evidence in that regards, in that end. So. Great. Thanks, Greg.
Thank you.